The most widely published book in human history reveals that we are created in the image of God. Throughout our human journey, each encounter is an opportunity to see the shared humanity in ourselves and others. Regardless of one's views on religion, each experience and each story weaves us together towards a common path. A path of transformation, a process of growth and understanding, a recognition that, at our core, we share a common destiny. What does the search for truth really mean in our lives? How can we find a sense of unity in a world so diverse and divided? As we reflect on these questions, we start to uncover a fundamental connection that binds us all beyond our differences. Welcome to Created in the Image of God, Building Vibrant Communities, with our host, Wade Franson. Tonight's episode is The Wonderful Universe.
Hello, everyone. Wade Franson here with Created in the Image of God. For those who are familiar with the show, you'll notice I have a little bit of a different background. No, it's not one of those background screens. I'm actually in the observation deck at the Kelowna Airport in British Columbia, where my son and I have been stranded for the last 24 hours or so. Our flight was canceled last night. First delayed, then canceled after midnight. We finally got to our hotel at about 2 a.m. and managed to get a few hours sleep. We've been back at the airport. We're waiting to go through security here right at the end of Creating the Image of God. But I'm hoping this shows the dedication to this show. And it's also somehow, strangely fitting that I'm in this observation deck at an airport, because our guest tonight happens to be somebody who observes space. And much more than just airplanes and the space around our planet, but deep space. She's actually an astrophysicist. Now, I don't have my second screen to go through her full bio the way I normally do, but she's an accomplished astrophysicist, and I'll invite her briefly. And she won't want to do this because of her, basic humility, but invite her briefly to describe some of the accomplishments. From my recollection, she was actually involved in the naming of something through her prior observations, and she's worked on various projects. The reason I've invited her to be on the show is that awe and wonder factor. She brings a Christian perspective, a religious, spiritual perspective to her work, and therefore, when the Bible says the heavens declare God's glory, she's looking for it. Let's invite her into the studio now. Welcome to the studio, Jennifer.
Thank you, Wade.
And putting you on the spot, I know, nobody likes to toot their own horn. Well, some people do. I won't mention any names. Some people do like to toot their own horns, or trumpets, as it may be. But let's invite you to share just a little bit about your background and your accomplishments.
Well, I am an astronomer, or more specifically, an astrophysicist. That simply means that I'm a scientist who studies the universe, and truly filled with wonder, as the title of this episode says. So my background is that I'm trained as a radio astronomer using these big dish telescopes that you may have seen in various places that can receive a type of radiation from deep space that our eyes and our ears are not attuned to, but there's a lot of information radiating through space in these kinds of light that we can't pick up without special telescopes. And in my case, I've used those radio telescopes to peer deep into these clouds that inhabit the galaxy between stars. And it's in these dense clouds of gas and dust where new stars are actually still forming. We can talk about that a little bit later. I've also had experience in more science oversight, science policy. I spent a little over a year working on Capitol Hill as what's called a congressional science fellow. Now, this was back in the early 2000s, but I helped the science committee for the House of Representatives think through science issues. And it was great for me to get that perspective of what science looks like from the legislative perspective as opposed to from the academic perspective. It was really interesting. So I've had experiences in different scientific institutions over the years, the National Radio Astronomy Observatory, the Johns Hopkins University, and NASA. And I've enjoyed all of those experiences. And I've had experiences using different kinds of telescopes, the radio telescopes that I mentioned to you, but also telescopes in space, like the Hubble Space Telescope and other types of facilities to help us understand different aspects of the universe that we're studying. But before all that, Wade, I was a country girl. I grew up in rural Arkansas and in a small town in north central Arkansas called Mountain Home. That gives you a little hint that it's nestled in at the edge of the Ozark Mountains. It's a beautiful area of the country. I still go back there as often as I can and visit the family farm. And it is a place where you can see lots of wildlife. And when I was growing up, it was dark there, so you could see the night sky. That's a rare treat now, right? Because most people around the globe live in a city or in a suburb where we have bright street lights and parking lot lights and highway signs, and they're all creating this light pollution. We call it this excess glow of light that fills the night sky and makes it harder to just look up at night and see a sky filled with stars. But when I was growing up, you could see a lot of stars, and it made me curious. And I also grew up at a time when we were getting some of the first images back transmitted to Earth from these probes that we'd sent out from planet Earth to fly near Jupiter and Saturn. These are the Vikings. Do you remember the Viking probes? So they sent back close-up pictures, not only of these planets, but of their moons. And so when I was growing up, I was just fascinated by these exotic worlds that we were seeing. I watched the Cosmos program every week on television and was just in rapt attention and thinking about space and wanting to be somehow part of that exploration enterprise. I had no idea how to do that, but so I can keep going. But I did benefit from the encouragement of people, even in that rural area, who helped me feel confident that I could go on and study science, go on to college. My parents were not able to go to university, but they made sure all four of their kids were able to. So I appreciate that. And my oldest brother, Michael, and his wife, Carol, were very encouraging to their younger siblings. And when I was growing up, they would give me little science related items for birthdays and Christmas and so forth. And that just kind of made me think that, hey, you know, science and using the mind is a good thing. And I felt encouraged. My teachers in this public school system were very encouraging, very dedicated, also the guidance counselors. And so they encouraged us to reach high, even to try unusual things for our community. And so I did, at the encouragement of my older brother and teachers, apply to different kinds of universities. And my parents, thankfully, were willing to make sacrifices to support my going and studying science at a more distant university. And I'm thankful for that. And then finally, I'll just add that my church family in my hometown was encouraging too. We didn't have any professional scientists in the area, but we understood growing up that all of creation is God's handiwork. So, you know, what I gleaned from that is surely science is good, because science is helping us understand the details of creation, and I still feel that way. So it's all of that together that kind of launched me into a scientific career from growing up on a small cattle ranch in Arkansas.
Well, thank you so much for sharing that background, and certainly helps us understand a little bit where you're coming from, where you're going. A couple of thoughts just to add to that. I find it it's wonderful that here in this observation deck, there's nobody here because it's perfect for me doing the show. But it kind of brings into relief, the hustle and bustle going on around me and down there, and that we're about to get engaged in. And people don't stop to smell the roses, and they don't stop to observe, right?
Yeah.
There's nobody here, and it's a beautiful area, and it's actually the nicest, quietest place to sit. And there were many others whose flights were canceled. You follow me?
No,
So I would have thought that there would have been a variety of people like us sort of stranded and needing something to do. And yet no one thought to come up to the observation deck except me. It's interesting. The other thing is light pollution you mentioned, because we were on the Big Island. And so we went up Mauna Kea there's, two-tiered, you can rent a 4-wheel drive and go all the way to the top, or there's a big observation area where they have some buildings and whatnot where you can stop. And so you go up there to observe that same now rare situation of, away from light pollution. I had that experience in the Sinai Desert when I was on the City of David archaeological expedition. And so we were digging deep into the tells and, in the dust and dirt of ancient civilization. But also then in the Sinai Desert, we were camping out there. It was just stunning. Never experienced anything also up in Alaska as a kid in a tent with no water, no electricity, having the same experience. But here we are in Mauna Kea, and lots of tourists there for this purpose. But they couldn't stop getting in and out of their cars and having their car lights on. And, every time somebody opened the door, the car light would go on. And it ruined the whole, my kids were like, Dad, chill, right? Dad, just chill. I'm like, no, we're going to go out here away from the cars further in the dark to get this. I wanted my kids to have that experience. And they didn't get it because people were heedlessly not fully taking advantage of that moment of awe.
Yeah. Well, that is an unfortunate example of all the distractions that are around us that make people unable to recognize the wonder that's all around us. And it can be, looking up into space, but it can even be looking right around the sidewalk where you live and taking time to look at those amazing clovers growing there and how beautiful they are, or look at that bug that you thought was disgusting and you just wanted to shoo it away. But when you look more closely, it's got a beautiful, intricate wing pattern. I mean, paying attention is something that we have to be intentional about. And I'll just add that I think one of my formative experiences that set me up to be able to appreciate the universe and the time that it's taken for the universe to take on the grandeur and the richness that it has actually occurred in an underground cavern system. Because where I grew up in the Ozarks, there is an area called Blanchard Springs. I encourage everyone to be adventurous and go visit Blanchard Springs sometime. But Blanchard Springs is a beautiful area buried in the Ozark Mountains of Arkansas, and it's a nice park in its own right. There's truly a big spring there with water gushing out of the side of a small cliff there. But it turns out that water is gushing out from an underground cavern system. The full extent of it wasn't even discovered until just a few decades ago. And it is one of these big systems. You may have heard of Carlsbad Caverns. Well, this is, every bit as grand, but still a living cavern system. So the water is still forming these beautiful features, these big columns that we call stalactites coming from the top of the big cavernous rooms underground, and the water is dripping down from these mineral-based columns, and then dripping from the end of them to the floor of these cavernous openings and building up from the bottom. Those are called stalagmites. And over time, the drip, drip, drip of these drops that have minerals in them builds up as the water evaporates away and leaves behind the minerals, builds up these columns. The stalactites are growing from the top, the stalagmites are growing from the bottom, and eventually they join and make these beautiful columns. Usually they're kind of a white color. Some of them look like curtains. So you're walking around underground now in this fairly recently discovered cavern system, and noticing just this incredible beauty that you can only see if you bring a light into the darkness and shine it. And I, as a child growing up, loved to go there because it was beautiful, but it was just awe-inspiring for me as I thought about how long it must have taken for one drop at a time for these water drops to deposit tiny bits of minerals. And here you end up having this resulting cathedral rooms of stalactites and stalagmites and these curtain-like features of beauty. And I understood from that it takes time. Nature takes time, long periods of time, for things to form and to come to the fullness of beauty. And I think that really prepared me for understanding that the universe as a whole is not something that's that's come to fruition in a zippy fashion. It's taken a long time from our perspective for the universe to develop into the rich and abundant place that it is, and it's still developing. So I think that was one of my formative experiences of awe and wonder.
Well, that's amazing. Thank you for sharing that. And I've got a couple of thoughts here on how to sort of launch the next segment when we come back in this video that tees off on that. So for everyone in the audience, don't go anywhere. We'll be right back after this brief little commercial message, if you will, that's tied into this theme of the show. But we'll be right back with more of Jennifer Wiseman on Created in the Image of God.
For centuries, physicists have sought to explain the universe, from the grand dance of galaxies to the invisible world of subatomic particles. But what happens when the act of observation itself changes what we see? When consciousness, the very thing that makes us observers, becomes part of the equation. Physicists have found that the lines between the observer and the observed are blurred, making consciousness a puzzle they cannot ignore. To unlock the mysteries of the cosmos, they must understand the workings of the mind. This book explores the deep interconnections between quantum mechanics, cosmology, and human consciousness. Can the structure of the brain reveal the secrets of the universe? Can the laws of physics help us understand the nature of our own awareness? Join George Musser on a journey to the cutting edge of science, where the quest for a theory of everything meets the profound mysteries of the human mind. Could understanding the universe start with understanding ourselves? Putting Ourselves Back in the Equation by George Musser. Available now.
Welcome back to Creating the Image of God. We're here with Jennifer Wiseman, astrophysicist. Right before the break, we were talking about the cavern system that was recently discovered from her childhood area, and the awe that was achieved when she brought light into that cavern and observed it. And she was talking about how things take time in nature. And I was reminded of a couple of thoughts. We were talking right before the show launched about how many people in trying to engage, the common man, if you will, in discussions of this nature, anthropomorphize their discoveries. And I think his last name was Edo, E-D-O, this person who was involved in writing about this when I was doing some of my own writing, talking about radiation or radiology images that are coming back that now allow us to, I don't know if that came through, I'm getting an announcement here, but the authenticity here, right? But that those images from the early years of the birth of the universe were like getting a picture of a 2-year-old that you had never found before. So it is fascinating to get that dimension of time in there. But even more important, this idea of light, because I was thinking about how light is, the fastest thing we know of in the universe, right? The speed of light is that constant. And so light travels, from our mind almost instantly anywhere, and it reveals whatever it hits upon. At the same time, it's the easiest thing to stop. You can stop the light by holding up your hand or a piece of paper. It doesn't force itself on anything. It can be easily stopped. You can't even feel that you're stopping it. If you're stopping sound waves, you maybe even feel it a little bit, and they can be stopped. We had a family at our home for Memorial Day, or it wasn't Memorial, but recently, a week or two ago, and their son was in the pool screaming at the top of his lungs and saying, "Mom, can you hear that?" And coming up, "Can you hear that?" And no, we couldn't hear it. When he was underwater talking, the water muffled the sound. So sound travels too, but not quite in the same way as light, and they reveal different things. And then on the way to the airport, when we took this trip, I had these polarized glasses on, and there was some kind of like almost rain situation, and I saw something I've never seen before. I had to take my glasses on and off, and I gave them to my son. I saw this vast, broad rainbow. Not your typical rainbow, but wide swath band of rainbow covering half the sky. And it was beautiful. It was faint, and I could only see it when I put the glasses on, but it was there, and I took them off and I couldn't see it. And so light passing through water changes and reveals a completely different element that we hadn't seen. All these things are going through my mind leading up to this show. And now turning the mic back over to you to share, what are we learning? What are we seeing? What is that awe and wonder? And I know you even have a few slides that you want to share with us.
Yeah, it's really hard to have a conversation about the heavens without showing some pictures. Although I do want to caution us that there are different kinds of light, right? So it's true that while, our hands can stop in a sense visible light, which will simply reflect off of our hands, but there are other kinds of light that can just go right through. I mean, we already know about X-rays, and so there are different wavelengths of light that have different properties, and if we learn how to observe them coming from different aspects of the universe, we can learn different things that we would not learn if we only saw visible light. So is it okay if I try to share just
Please.
a few pictures here? We'll see. We'll hopefully be able to take a peek. Can you see this?
There we go.
Okay. So this is an example of what I would call beauty in the universe. This is a nebula of gas with a recently formed cluster of stars in the middle. The region's called NGC 3603, but it is spectacular, and it's an example of a region in a galaxy, our galaxy, where there's a dense cloud of gas and dust, and if little clumps within those normally turbulent clouds has enough density, the gravity that tries to pull matter together will dominate, and you'll get clumps of collapsed gas. If there's enough matter, the pressure gets very high in these little clumps of gas, and in the middle it can actually press atoms together, and they will go through a process called fusion. So hydrogen atoms fuse together and create helium atoms and heavier atoms. And so the product of that whole little process is heavier elements, but also photons of light are produced, and they eventually escape the surface of this clump of compressed gas. And that's what we call a star. So a star is just a little factory that's creating heavier elements and also light. That's what our sun is doing. And stars can also create winds, and they can go back into the surrounding gas, the surrounding cloud out of which the stars have formed, and start to kind of blow the wispy gas away and carve it out into sometimes pillar-like structures. So you see that going on in this image. You see this cluster of stars in the middle, more massive than our sun. And they are shining brightly. Their radiation is lighting up the surrounding gas in a process called ionization that gives it the color. And so when astronomers see these beautiful, colorful nebulae with telescopes, we say, oh, that's beautiful. But we also say, wow, that means that star formation must have been relatively recent, because after a while, the winds from those stars will blow away all that leftover gas, and you'll just have stars. It's also just beautiful. So when I look at something like this, I think, wow, the universe is beautiful, but it's also active. It's not stagnant. And one of the things we've definitely learned in recent decades with our telescopes getting more and more sophisticated is that the universe is vast, but it's also active. We're seeing stars still in the process of forming. And in very recent decades, we've found out that stars, other than our sun, also have planets. We didn't know that when I was in school. And now we know that planets are common orbiting other stars. And so the rush is on to try to find out what those other planetary systems are like. But we also know that stars eventually run out of fuel, and that's an active phase as well. When they become old, they can become unstable and actually release those heavier elements that they have forged during all of those years of their shining, which can be millions or even billions of years, and releasing it back into these interstellar clouds, and they can enrich subsequent generations of stars. So that was kind of a surprise when we realized that our solar system is not a first generation star system. It's benefiting from previous generations of stars that have created heavier elements. Let me just kind of show you what telescopes look like. My favorite way of looking at the heavens, we've already discussed, is just going out, if you can find a dark place, and looking up with your own eyes, because that is the way you really feel most connected with the universe, is if you're actually looking yourself. But it's hard to find a dark place these days. But even looking at the moon, I mean, we think we've all seen the moon. Why bother looking at it again? But if you look carefully at the moon, and even just with a pair of binoculars, you're going to see amazing features on the moon that will just blow your socks off. So take time to look even at the moon. Here's a pair looking with a backyard telescope, and people's personal telescopes now have gotten very sophisticated in recent years. People privately own telescopes now in their backyards that are better than the telescopes I had back at MIT going to college to use, in sophisticated courses. So it's a great time to enjoy astronomy. There's lots of astronomy clubs in different cities, different areas. Those are great to either join or pay attention to, because they sometimes have star parties, and you can go and look through other people's telescopes at the night sky. Professionally, we use different kinds of telescopes because they all have a different capability. So we have telescopes in space. What you see on the top there is an example. That's the Hubble Space Telescope, named after astronomer Edwin Hubble, and it's orbiting planet Earth. It's not very far up. It's only a few hundred miles up, so that it gets above the clouds, above the atmosphere, to get a sharper view of deep space. And it has to orbit the Earth very fast to keep it from falling back to the ground. Hubble is in good shape even after decades, because of astronauts repeatedly going back and upgrading the telescope and making repairs. So it's doing tremendous science. But we have other telescopes in space as well, such as the Chandra X-ray Observatory and the Webb Space Telescope. These observatories see different colors of light. Hubble seeing visible light and ultraviolet light, Webb focusing more on infrared light. Chandra, seeing X-ray light. There are smaller space telescopes as well that have unique capabilities. And soon we'll be launching something called the Roman Space Telescope, named after astronomer Nancy Grace Roman. She's famous for being the first chief astronomer at NASA and advocated back in the 1970s for the idea of a space telescope. So she's sometimes called the mother of Hubble. But the Roman Space Telescope will see bigger swaths of the sky than Hubble and Webb can see at any one time. And that will enable us to do surveys of how galaxies are distributed, teaching us something about how the universe developed over time. In the lower images here, you just see examples of other kinds of telescopes. We still do use telescopes on the ground, and they have great uses. So an example are the Keck telescopes on the lower left. Those are in Hawaii on that mountain you mentioned, Wade, Mauna Kea, what we hope is a dormant volcano in Hawaii. But again, we try to get telescopes high and dry. They can get the best view when we can do that. The lower right is an example of an array of radio telescopes in South America, the Atacama Large Millimeter and Submillimeter array of telescopes, and they are extremely precise at observing these galaxies and these dense clouds, as I mentioned, where stars are forming. So all of these different telescopes have a different capability in terms of the kinds of light they see, or the cadence at which they observe, or the field of view in the sky. And so astronomers typically use a combination of telescopes to study whatever it is they want to learn, whether it's something about the solar system or something about other star systems and their planets, or other galaxies, or this interstellar gas. All of it requires these professional tools. And they are just opening our eyes up to an amazing universe. So what I showed you in that first picture was one of these interstellar clouds in our own galaxy where stars are still forming. But these nebulae, these clouds and stars, make up the volume of entire galaxies. These are collections of stars and gas. There can be hundreds of billions of stars in a galaxy like the one you're looking at. And there's so many stars that the light blends together right there in the core, so it just glows. We think our own Milky Way looks something like this, but we can't get all the way out to look back and take a selfie. So we just have to kind of look around from our own star's position, which is along one of the spiral arms in the Milky Way. And we think we live in a spiral galaxy. If you look closely, you can see some other galaxies in the background of this beautiful, spectacular image. This image, just like the nebula I showed you, are images from the Hubble Space Telescope. What you don't see here is that most of the matter in these galaxies is unseen. It's called dark matter. But we know it's there because it's affecting the motions of stars. We can see its gravitational effects. Let me just show you a couple more. I just hope you're feeling a sense of awe and wonder already. So that was one galaxy. I told you that a galaxy can be filled with these nebulae where stars are still forming, and galaxies can contain hundreds of billions of stars. Well, now we know there are hundreds of billions of galaxies. And here's a mind-blowing example. So this is one of the early images from a new observatory that has come online that was built in South America. It's called the Rubin Observatory, the Vera C. Rubin Observatory, named after another astronomer, a woman named Vera Rubin, who nailed the existence of dark matter in galaxies through her careful observations of the motions of stars in them. This new Rubin Observatory has a wide field of view, so it's designed to make surveys of wide swaths of the sky. And here's one of the early examples. These dots and smudges of light are not individual stars in our own Milky Way galaxy. They are other galaxies outside of our own. And they are beautiful, right? You can see different spiral-shaped galaxies. You can see yellowish smudges. Some of them are closer to us, so we can see more detail. Some of them are farther away. Some of them are interacting with each other. Like if you look up in the upper right, you see 3 or 4 galaxies where the light's kind of connecting them. That's because they are gravitationally getting entangled and they're siphoning off gas and stars one to another. Eventually, those galaxies, as they rotate around each other in a kind of dance, will merge and create a bigger galaxy. We think our own Milky Way is the product of some mergers in the past and will be again in the future. So merging and growing is a part of our cosmic history. And in fact, this image, of course, has a third dimension. Some of these galaxies are closer to us than others. And as you mentioned, Wade, it takes time for light to get to us. So we're seeing all of these galaxies as they were in the past, when their light started its trek across space to get to our galaxy and our planet and our telescope. And the ones that are farther away, it's taken longer for the light to get to us. So we're seeing them as they were earlier in the universe. We're seeing them as they were back in time. And those more distant galaxies truly are more primitive than the galaxies we can see closer to us in space and time that have had more time to develop. They call this image.
Can I just jump in with a question there on this one?
Sure.
Or it's kind of a quasi question, quasi comment. It strikes me when this image first came up, I immediately thought, wow, diversity, right?
Yeah.
It's not a homogeneous like visual of, you know, a bunch of particles that are the same, or a substance in which you have particles that are all the same. There's an incredible amount of diversity here. But the other side of it is, as you just mentioned, the time element, the time dimension, which caused me to reflect that this is just one perspective. It's not even real in that sense, because the time frame of the light would be different, would it not? Some of these galaxies are being shown at an age that is not correlated in time to the age of other things in the image, right?
Correct.
So because of the way that light has to travel, this particular set of things never existed as they are shown here, which tells us the unique nature of perspective, not able to grasp the full reality of something.
Well, I would say that they've all existed as we see them in this image. It's just that they were looking like this at different epochs of time.
Exactly. So this particular image never actually existed. It's a fascinating perspective, and it's an incredibly valuable one, but it's complex. It's multi-dimensional, multi-layered, as you were getting at.
Yeah. Well, you know, astronomy is a terrific time machine in that sense, because we can see different epochs of time all at the same time to us. And so we can tease that out. In fact, if this next image kind of explains that a little bit better, as you see in this graph, it's trying to depict how over time, which is going from top to bottom here in recent years, as our observatories and as the cameras that are within them get more and more technologically sophisticated, they're able to see fainter and fainter things in deep space. Well, that correlates to seeing faint galaxies that are farther and farther away. So that's what those arrows are depicting. You know, we're able to see farther and farther away into deep space. But of course, seeing farther out, as we just discussed, means that we're seeing things as they were earlier and earlier in the universe. So the bottom axis there is time going from right to left. And off the right side of this image would be the beginning of the universe. You know, every piece of evidence now points to the fact that our universe, the one we're experiencing, had an amazing beginning about 13.8 billion years ago, what I call the let there be light event, but really a burst of inflation and energy. And then shortly in cosmic time, the first atoms, molecules, gas formed. That enabled the first stars, first galaxies as collections of stars and gas. And we're seeing some of those infant galaxies from within the first 0.8 of that 13.8 billion year history of the universe, with telescopes now, like the Webb Space Telescope, that's very sensitive to these early infant galaxies. And we can compare them to galaxies that are closer to us in time and space. So we're kind of going from right to left in this picture. We can see how galaxies have merged together over time. We see lots of galaxy mergers going on in the distant universe. And then we can see how galaxies have grown, how stars within them have come and gone and created the heavier elements, so that the composition of galaxies like our own and galaxies nearer to us in space and time, they have stars and gas that have a lot of these heavier elements that do not appear in the galaxies that we're seeing early in the universe. And so we're actually able to tease out how the universe has progressed over cosmic time to become more complex and more hospitable to life. And that to me is just amazing. Here's some examples of galaxies picked out from these deep fields observed with telescopes. And the more distant ones in space and time, like the ones on the right here, are kind of ratty looking. They haven't had time to merge and grow with other galaxies. They haven't had time to create many of the heavier elements that we enjoy in our own Milky Way. The galaxies on the left are closer to us in space and time. They've had more time over cosmic history to grow, and their compositions are more complex because of the heavier elements that they have. That includes our Milky Way. So it is true, we cannot follow a single galaxy and watch it change over billions of years of time. We don't have that kind of capability, but we can see populations at different phases of time and see how they differ. So that's a glimpse at our incredible, awe-inspiring universe. And as I said, even closer to home in our own Milky Way, which we think looks something like this, we're discovering that planets are common. So a real hot topic in astronomy right now is studying these exoplanets, planets orbiting stars outside of our own solar system, trying to see if they're like planets in our own solar system. And of course, eventually we'd like to know if any of them are actually habitable for life, even simple life. And then another hot topic on the cosmic scale is that it seems like the universe, which is expanding, we've known that since Edwin Hubble did his astronomy 100 years ago, space is stretching, galaxies are moving apart from each other with that stretching of space. But what in recent years we've found is that expansion is accelerating. We don't really know exactly why that is. We're calling it dark energy that's driving the acceleration of the expansion of the universe. So that's a mystery, just like dark matter is. We don't really know what dark matter is, but these are interesting and delicious puzzles that astronomers and cosmologists are studying these days, as the field of astronomy is really vibrant right now. I'm going to stop sharing if that's okay.
Absolutely.
All right.
Well, wow. Thank you so much, Jennifer, for walking us through those delicious slides and explaining. We've probably all seen various images like that, but to have a guided tour of the kind that you gave is just wonderful. So, one of the questions that comes to my mind as we, work through this middle segment here of the show is, well, it's not a question. Again, it's kind of a comment, and I'll like your input on it. When we talked a few months ago, I kind of asked, is your perspective unique, right? Because many religious people, many Christians might think, in terms of atheists versus believers, right? And scientists, and it may well be considered by many to sort of be not people of faith. But I recall you saying, well, that's probably not true, that there are a lot of people who have various degrees of belief and share some of that awe. Any comments on your particular approach to this study, to your work, and others in your field and how they approach it from that perspective, to kind of bridge that gap between Because I've commented recently, it almost feels like we're in some kind of ideological civil war in our country with these echo chambers and the increasing polarization. And I have the feeling that, the real people on the ground at the cellular level, they're not that different.
Sure. Well, I found that astronomy and looking at the heavens is a great unifying activity, because I don't know of anyone, no matter what their political or religious perspective is, who is not just amazed and awestruck when they get a chance to see some of these images, or even better, look through a telescope themselves or look up at the night sky. And that's as it should be. We really need, as human beings, to find things that we can find shared awe and wonder about. In terms of the scientific community, it's been my experience amongst practicing scientists that there's kind of an understanding that science has limits. Science is a wonderful tool, but it's a wonderful tool if you use it for what science is meant for. And science is really meant as an approach to do systematic measurements of the natural world, whether that's in biology or astronomy or geology. Whatever it is, we use tools where we can take measurements, hopefully repeatable measurements, and ask some question about the function or the behavior of processes or material or forces within the natural world. And for that, science is a wonderful gift. I think of it as a wonderful gift from God, as a tool to help us understand more details about the natural world. But science, as we practice and understand it today, was never meant to be like an overarching, almost like a godlike sort of a religious ideal that can answer every question and everything about everything. It's really not designed to answer certain types of questions. Science cannot answer questions about, who should I go to the movies with next weekend, or more substantive questions like, is there a God, or does God answer prayer, or some people have tried to force those kinds of questions into experimental situations, but it doesn't work well given the nature of the questions that are being asked.
Yeah. Well, I think of the term the science, right? And if you reflect back, there's kind of an evolution, right? The idea might be, well, we should invest, or we should look at the science that's available on a certain topic, right? Which is great. But then when you start using the term the science, and suddenly that becomes like its own thing, as though, do you understand what I'm getting at? And
or I think you have to watch out for what we call scientism. So, sometimes science is seen as maybe the ultimate arbiter of all truth. And to some degree, it is very helpful. You can say people can have different opinions about this or that or the other, but if there are questions about how the natural world works, you can say, well, let's look at the science, because if we're doing it right, we can take a measurement, it's repeatable if we're asking the right question, if we're doing it the right way, and that's informative. But it has to be a tool that matches the kind of question for which the scientific tool is useful to address.
Right.
And I would
And
say,
so,
yeah, that goes
so
on.
again, even as I'm reflecting in my own head here, this is fascinating, because the term the science is describing something that kind of doesn't even really exist. Because you can do a survey of scientific findings on a given topic. But again, the term the science is something bigger and broader and less accurate. And it's like a sledgehammer, when what you really need is some kind of sensor. You know what I mean? So the language itself, and this brings to mind something I wanted to bring up. You mentioned that Tremper Longman, who we just had on the show, is a friend of yours, and I wanted to refer to another scholar we just had on the show, Gary Rensburg. And Tremper knows Gary. You may not know Gary, but Gary Rensburg is a preeminent scholar on the Dead Sea Scrolls in particular and the Book of Genesis, and he looks at the Bible as literature. And I'm fascinated by Gary's work, and I was privileged to interview him. And I asked him the question, on a personal level, Gary, you obviously bring respect to the Word of God. And as you're studying the Dead Sea Scrolls and as you're producing findings on what you've come to understand, you bring respect to it. I said, but on a personal level, do you bring reverence to it? And the answer to that, if you do bring reverence to it, do you kind of have to hide that in the world of scholarship? Because if you bring reverence to it, then your scholarly work is going to be somehow brought into question. You follow me? So why am I bringing this up in this context? Again, it comes to this idea of detachment, and to truly be able to do science, one has to not bring light pollution in the sense of, or pollution into the equation by bringing one's own ideas and biases too strongly. One has to begin to, or be able to sort of identify, I'm coming at it from this perspective, but I want to be careful that I'm not bringing in too much of that into my review or research. Do you understand what I'm getting at?
Sure. And so scientists we're very careful to try to be as aware as we can of our own assumptions before we set up an observation or an experiment. But we are humans, so being, cognizant that it really is impossible for us to be kind of completely objective when we're doing science, because we live in a culture, we live in, even deciding what are the interesting questions to
exactly
address.
Which hypothesis do I want to pursue is itself kind of bias, if you will, but that's fine, because that's the question that interests me or you or somebody else, and therefore and in the scientific community, peer review, somebody else will bring a different perspective to then review and evaluate what you did.
So I in astronomy, we have in the United States, we have something called the Decadal Survey, which is a very comprehensive conversation, basically, run by the National Academy of Sciences to bringing together some of the top physicists and astronomers from across the country to think and talk for many months to come up with what they feel like are the most important questions that humanity has right now about the universe that can be addressed with telescopes. What are the top priority questions, and what are the facilities that we need to address those? So, but it is an example of how the kinds of science that we as a culture choose to do and to support and to care about is generated from human interest, human curiosity, and that's culturally driven. I think the practice of science is very strong and robust because it is, to a large extent, self-corrective. That what was, the scientific consensus on many things a few, decades or years ago is changing because we get more observation. That's the way it should be. And so it will continue to be that way. It's a strong method, but it isn't the right tool to answer some of these bigger philosophical and religious questions. You need a different tool. Those are not bad questions. They are, in fact, more important in many ways than the kinds of questions that scientific tools can answer. But I think people, we get in trouble when we try to use a scientific tool to answer a bigger religious or philosophical question, like, is there a God and what is God like? And likewise, when we try to use religious revelation and tools like the scriptures to try to answer very specific scientific questions, because that literature or revelation, if you will, was not meant for the purpose of addressing meticulous questions about how atoms and molecules work. Generally, religious texts are meant tell us something about ourselves and something about God and how to have a relationship with God. So I think a lot of the challenges we have sometimes in relating scientific knowledge to the other values that we have as human beings often comes down to making sure we're matching the right tool with the kind of question that we're trying to address.
Well, that's a perfect segue on two fronts into a quick commercial break, and when we come back, asking the question of where are you growing next, and what are those questions? In that every decade survey, what are the big questions, and are you going to be looking into any particular ones? What do you think's on the horizon? What's next? Don't go anywhere. We'll be right back on Created in the Image of God with Jennifer Wiseman.
In a world where religions often talk past each other, what if we just sat down and listened? Facets of One is a simple devotional, bringing together scripture from the world's faiths, centered on one truth: God is one. From the Bible to the Quran, from Krishna to Christ, each voice speaks in turn, without argument, without division. You don't have to agree on everything. Just be willing to pray, to listen, and to come together. If you're longing for something deeper than noise and division, this is a different kind of conversation. Facets of One. Many voices, one God. Will you start a circle?
So thank you so much, Jennifer, for introducing that big picture, universal scientific quest to understand creation, the universe, and our place in it. Right before the break, you mentioned that every decade or so, there's some reflection, some discussions. Tell us a little bit more about that event and what's come out of the most recent one and what's next on the horizon for in broadly speaking, and also for you personally.
Sure. So this decadal survey, as it's called, is something that guides in the United States how we set priorities as a nation for funding astronomical sciences and what kind of facilities we want to support, be it space telescopes and telescopes on the ground and the instruments that go in those telescopes. And so those decadal surveys have been tremendously helpful to kind of make our scientific leaders think hard when we have limited resources. What are the most important kinds of questions we want to address in the next decade, and what are the facilities we would need to do that? So those decadal surveys have ended up, making recommendations that have led. Of course, it takes many years after the recommendations to actually make some of these things on the wish list really be manifest. But they've led, after the Hubble Space Telescope, to the Webb Space Telescope, which now complements Hubble. They see different kinds of light. This newer Roman Space Telescope that will be launched just in the next couple of months, we think. So that's exciting, but that was the result of the highest priority of a previous decadal survey. And then some of these facilities on the ground as well. I think some of the highest priority questions, scientific questions that are coming out through these surveys involve on the local scale, trying to understand more about these exoplanets. What are these planetary systems like that are around nearby stars? And how are we going to find out if any of them even have simple life? We can't travel to these places yet. We don't yet have warp drive, so we can't yet get in spaceships and make a trip, unfortunately, to other star systems. But we can receive their light to our telescopes. And if we build clever technology, we can understand something about what's going on in the atmospheres of those planets around other stars, what's going on in their parent stars, and would the interaction between the stars and their planets be similar or different than the interaction we have between our sun and the planets orbiting the sun? And are there telltale signs in the atmospheres of these exoplanets that tell us that there must be some kind of biological activity going on that planet, in its atmosphere, or on its surface? And so those are the kinds of things that are a high priority in astronomy right now. And kind of on the other end of the cosmic scale are questions about the universe as a whole. I think I mentioned earlier, but there were a couple of surprises in the last century. One is the detection of this unseen dark matter that seems to be most of the matter in the universe, and yet we don't see it, and we can't account for it, even if we imagine, the largest number that's feasible of small stars or planets or anything like that. It just doesn't add up to the amount of mass that we know is there by seeing its gravitational effects on other things that we can see. And so what exactly is dark matter, and how does that relate in the history of the universe to something called dark energy, which is a more recent discovery? That's kind of a generic label put on this phenomenon of noticing that the expansion of the universe, which we always thought when I was in school should be slowing down because all the galaxies and the matter in the universe should be tugging on each other, and that would slow down this expansion. So the question was whether there was enough mass to bring everything back in again in a big crunch or not. But instead, what we seem to be seeing through meticulous observations is that the universe expansion did slow during the first few billion years of our cosmic time, but in the more recent billions of years, that expansion rate is not slowing down, it's speeding up. And so the dark energy that is driving this, we don't really know what it is and how it relates to the nature of the universe toward its very beginning. And so studying that interplay of dark matter, which has got a gravitational pull, and dark energy, which seems to be pushing the universe apart, over cosmic history is a hot topic in astrophysics. It requires looking at the background radiation more carefully that's come from the very near the beginning of time and fills the universe, and comparing that to what we measure in our current universe in terms of the expansion rate, and trying to understand how this fits together, how the interplay between dark matter and dark energy have enabled galaxies to grow and to be distributed the way they are in the universe today. This is important for ending up with galaxies like the Milky Way that can support planets and life. So, it's really important that dark matter and dark energy have the characteristics that they actually do. And we're also studying something called gravitational waves. This is a whole different way of receiving information from the universe. Everything I've been talking about up to now relies on observing radiation, light, as we started this program out discussing different kinds of light, X-rays, visible light, infrared light, radio waves, and even seeing indirectly the impacts of dark matter and dark energy on things we can see through radiation. But there's another way of information transfer across the universe, which is called gravitational waves. These are disturbances in space-time itself. And again, this is not a surprise if you believe Albert Einstein, but the surprise now is that, or the development now is that we're actually being able to detect these gravitational waves. These disturbances of space-time are most detectable if it's something massive in the universe that's had a disruptive interaction, like a merger of two very compact things like neutron stars or something like that. And that can create a series of detectable gravitational waves that our detectors on the ground can now pick up. and they're teaching us something even more about the fabric of space-time. So all of these are hot topics in astronomy and astrophysics, some of the highest priorities that will be addressed in the coming years. There's a lot we don't know, and there's still a lot to discover in our own solar system. So getting back close to home, my gosh, we live in a very interesting solar system. We have a wonderful star, the sun, that's creating conditions that we have to have for life on Earth. We're fascinated by Mars, that seemed to have oceans and rivers, lakes and rivers in the past, and now seems to be a frozen desert. But why? So we're trying to understand the history of Mars, why Venus turned into a big hot greenhouse and Earth didn't, and whether planets like Europa that orbits Jupiter could possibly have microbial life, because we think they have liquid water under an icy crust. So there's still a lot to detect in our own solar system. And I'll cap it off by saying that we are actually detecting now in our own solar system not only the comets and asteroids that we expect that are orbiting the sun, and they're fascinating to study, but we're detecting comets and asteroids that are passing through our solar system, and they're going so fast that we know that they didn't originate in our own solar system. They must have been somehow gravitationally ejected from another star system, traveled across the galaxy, and just happened to be passing through our own solar system. We call them interstellar objects. They're moving too fast to be caught by the gravity of our own sun and solar system. So we only get one pass to study them, but we can study something about the nature of other star systems by seeing the composition of these interstellar objects as they fly through. So all of these are fascinating topics, and they tell us something about the universe and its majesty, and that Bible verse you mentioned toward the end of the beginning of this program, Psalm 19, saying the heavens declare the glory of God. Well, if you read through that psalm, it says that they don't use words, they don't use speech, and I think
day after day their speech pours forth, and knowledge night after night. They don't use words, their speech. They don't use words, but their speech pours forth nonetheless.
Exactly right. So so I just think that's a beautiful psalm.
So, wow, and thank you so much. I've just been content to just sit here and listen. You've unpacked so much in such little time, but done it so well. I'm truly appreciative of you being here. I just guess I had a couple of thoughts here towards the end, but we're kind of out of time. So I'll just forego and just say, I think you put a really super nice bow on it. All these fascinating questions that we're now researching. I guess the one thought is that our capacity, and now the other one came back to me, so I will mention my two thoughts. The capacity to actually learn from these things. So these far distant relatives that are coming speeding through our town, we're in a position to learn something about them now that we might not have been before. The other thing is a Baha'i quote that simply says, God, it's talking about God, and it says, the most manifest of the manifest, the most hidden of the hidden. Dark energy, dark matter, dark is one way to say it, but it feels to me like they're hidden. We haven't figured out how to even see them yet. They could be very light, in the sense of bright, not light versus heavy or whatever. But the point is, our words even fail to describe in some ways these new things that we're learning.
Absolutely. And dark matter is just called that because it's not radiating radiation in ways we're used to looking for and detecting, but we can see its gravitational effects.
Yeah.
And I
reminds me of the Holy Spirit when you say that. Somebody asked Jesus about that, and he said, well, you see those trees, when they move, you see them move, but you can't see the wind. The Holy Spirit is like that. You see its effects.
Yeah, that's great.
You don't see it.
What a great analogy. Exactly. So that is a beautiful thought.
Yeah.
And
Well, we do have I'm going to go a couple minutes longer. We have a little time. We got to rush to dinner and get on our flight, but there were quite a few audience comments, and I want to just pull in just a couple of them. One of them here from very early on, from Eddie Bear. I'm just curious, is it mostly government type work as an astrophysicist? You talked about the big questions and the long timelines, and it takes a lot of money.
well, okay, so I'm not sure.
Because we also have SpaceX now, right? Which is an interesting development.
Sure. So exploring space means lots of different things now. So we're certainly sending humans into the local environment, into low Earth orbit. We have humans right now on the International Space Station. We have both, government space agencies facilitating space flight, but we also have private companies now that are facilitating space flight, transportation of both cargo and humans into the local region of our own solar system, and going back to the moon. As the Artemis 2 mission recently went around the far side of the moon and came back. So this is exciting, and of course we're hoping we can send humans even to Mars. That's a longer trek and harder, but it's possible. But we don't have the capacity to send humans to other star systems, and so we really have to have telescopes. I think I love your background distractions there, but the technology that has been growing ever since Galileo, several hundred years ago, Galileo used technology to take a telescope and take recorded observations of the heavens. And that method of studying the heavens since Galileo has grown more and more sophisticated. And it's that growth in technology, and in this case, using technology for what I think is something very good, that has enabled us to make these fantastic discoveries. And that enriches not only science, but it enriches these deeper reflections we have as human beings, philosophy, theology, even music and poetry. So here's a case where I think technology has benefited humanity. We all can think of cases where technology has brought harm to humanity. So, we still have to make choices about what kind of technology we develop and how we use it. But to me, astronomy is a wonderful use of technology.
Two more real quick. I got to pick here. There are a lot of really great comments.
Oh, I didn't answer the question. The question is, I think, is it only government entities that can do this kind of work? So it is true that astronomy, like studying deep space, doesn't have a lot of money-making potential, and I kind of like it that way. So it does mean that to do basic research, basic science, basic exploration of the deep universe, we depend on governments around the world and their peoples believing that that's valuable, so that they're willing to put in, a small fraction of their tax money toward basic science. And basic research can be curiosity driven, but it often results in benefits that become applicable to practical applications later on. I think of how basic research in gravity has informed us enough that we can now have GPS receivers, and those are very practical needs. So basic research does involve people willing to support it, but often it benefits us, not only enriching our basic understanding of nature and how we fit in, but also to some practical applications down the line as well.
Awesome. So here's one. I think we kind of answered that. How is it detected, dark matter? But just to reiterate.
Well, just quickly, originally dark matter was detected by noticing, for example, Fritz Zwicky back in the 1930s, astronomer discovered there were these clusters of galaxies where the individual galaxies were moving around each other, kind of like a beehive, and yet they didn't fly apart from each other. So there must have been mass kind of holding them together. And yet there must have been much more mass than you could account for by just what was visible in those galaxies alone. So he kind of scratched his head and said, there must be something we're not seeing. And then Vera Rubin back in the 1970s really nailed it by measuring the motions of stars as they orbit in galaxies and noticing that those stars were orbiting at very fast rates and yet not flying out of the galaxy. There must be more matter that we're not seeing in what we call the halo of these galaxies. And then the Hubble telescope, after it was deployed, started seeing a phenomenon we call gravitational lensing, which is where unseen dark matter in clusters of galaxies is actually distorting space-time, and that makes background galaxies, the light from those galaxies, get kind of stretched, distorted, and magnified. So we don't see the dark matter, but we certainly see its effects, and that's how, and we can see where it is and how much there is. So that's how dark matter is detected.
And then I apologize to the others that have been commenting. We've got time for one more before we go to quickly show the sneak peek for next week. It's this one here from Love a Good Mystery. I wonder what the fascination is with looking for planets that could hold life on places we'll never be able to get to.
Well, I think, we have as humans a fundamental question of, are we alone? I mean, certainly life on Earth is abundant. We have humanity, but we have lots of other life forms as well, enriching this planet. And so we ask ourselves, are we the only planet where there's this life and a diversity of life? And this is not a new question. Humanity has been asking this question as long as there have been humans looking up in the sky and wondering if there's life out there somewhere. What's changed in recent years is the absolute detection that there are planets abundantly filling the galaxy, and that provides more opportunities for life to possibly exist beyond our own solar system. And that's technology may even enable us to scientifically address whether or not there's at least what we call biosignatures on some of these planets that would indicate even simple biological processes. So the question of whether there's life beyond Earth is not new. It's something that's fascinated humans as long as we know humans have been looking at the sky. The ability to possibly actually scientifically address that in a repeatable, measurable fashion is on the horizon here, near horizon. And so that's exciting. And that's kind of what's changing rapidly.
Well, I've got to share a joke now that just occurred to me, because our former president, Reagan, who famously wanted to launch the Star Wars program, was known for telling jokes. And I just randomly heard this joke because somebody was playing a reel of his humor. And the joke was, this person fell off a cliff and he was hanging on. He was looking down below and he was praying, if there's anybody up there, tell me, what should I do here? And a voice came from heaven and said, "Let go, my son, in faith." And he looked down and he called out, "Is there anyone else up there?"
Yes, I've heard that.
So I guess that's part of the fascination in this blending of faith and science. Got another announcement here. I'm going to say thank you, give you the final word, and then go to the sneak peek.
I would say let's all keep our sense of humility and wonder. We live in an incredible universe. The more we observe, both on this large scale we've been talking about today, but also on the small scale, looking within our cells, looking at our DNA, even looking within atoms, it is fascinating from top to bottom. And it's ordered in a way that science enables us to understand at least a fraction of what we're seeing. I think that connection of the human mind and the ability to comprehend something of the orderliness of nature is a sign to me of purpose and purpose in the universe, that we are not just an insignificant accident in the universe, that we actually have been endowed I would say by God, to do these kinds of investigations, to study the details. And that is something that should give us, I would say, a sense of praise as well as wonder and awe. So I hope we can keep that childlike wonder when we look at the natural world. And also that we realize that, like it or not, we have stewardship over this planet Earth. We have dominion because what we do actually affects life on planet Earth of our fellow humans and also for other creatures. And we need to take that responsibility very seriously because we actually haven't discovered life beyond Earth yet. We might, but we know there's life on planet Earth. So let's take care of one another and the habitats on this planet so that all can thrive.
Well, thank you, Jennifer. I'm going to bottle that and use it to market this show, Created in the Image of God, because indeed we've been given that same capacity, as you mentioned, both to be stewards of this planet and also to ask those questions and to research and to seek and to knock and to find. So Jennifer, thank you so much for spending time with us today. And I'm going to just say we'll have to have you back again to dive deeper into this. And then for those who are watching, don't go anywhere. Here's the sneak peek of what's coming up next week. Jennifer, thank you. We'll see you soon.
Thank you.
Next week on Created in the Image of God. Sunday, July 12th at 7 a.m. U.S. Central Time, host Wade Franson interviews Graham Tomlin, theologian, author, and former Bishop of Kensington. He reflects on how Christians can engage culture with wisdom, conviction, and grace, and what it means to be a faithful witness in public life. From theology and mission to helping the church speak clearly and compassionately in a changing world. And then on Tuesday, July 14th at 8 p.m. Central Time, host Wade Franson interviews Vinoth Ramachandra, theologian, author, and international lecturer. He explores the intersection of faith, justice, and global culture, and challenges Christians to think beyond familiar assumptions and perspectives. From politics and suffering to a deeper vision of hope, discipleship, and engagement with the world. Join us live this week, Tuesday and Sunday, Created in the Image of God.